Okay, this video is going to be about graphing linear functions and describing their characteristics. So the first linear function I want to talk to you today about is y equal to. Now, of course, a linear function, you probably know or guess, the word linear has the word line in it. So when we graph these functions today, they're always going to be lines. It's a linear function. Y equal to does not have an x value. Okay, most linear functions you're going to have y equal something with an x. It could be a number that you multiply by x or add some number behind it. This doesn't have any x in it. So really, no matter what I pick for my x value, I'm supposed to substitute that x value into that function, but there's no x in that function to substitute it for. So no matter what I pick for x, y will equal 2. So let's just pick something for x. Let's just pick on the x-axis. Of course, the x-axis, goes left to right, so horizontal axis, and the y-axis goes up and down. Okay, so on the x-axis, I'm going to start right here in the middle, which means x equals 0. So when I substitute x equals 0 into the function y equal 2, there's no place to put that 2, so my y value is 2. So I go on my y-axis here's positive 1 on the y-axis, and here's positive 2 on the y-axis. I just put a point here at y equal 2. So when I pick x equals 0, y equals 2. Alright, if I pick x to be a positive 3, which would be right there in the x-axis. Well, again, there's no place to substitute that 3 into that function. Okay, so I'm going to y equal 2 again. So right here, I'll have a point here at y equal 2. If I pick x equal to, let's say 5, a positive 5, which is right there, is five numbers to the right of the middle, so that's 5, okay, y equal 2, okay. So here's another point at x equal 5, y equals 2. Now, what if we pick a negative number? Well, the same thing's going to happen. Let's say we pick a number here. Let's say we pick this at negative 4. The x value is negative 4. Okay, y equals 2. Okay, so no matter what I pick for x, my points are always going to be 2 blocks above the x-axis. And that's really what a y value is. It directs you how far above or below the x-axis do I put my point. Okay, so how do I draw my graph? Okay, well, I'm going to draw a line because it's a linear function. Okay, it's going to go right through these points that I have. So I'll draw this line right here. It's a blue line. Okay, and that's the graph of the function y equals 2. Alright, so let's talk about the characteristics. First of all, you see it's a flat horizontal level line. And when you have a y equal just a single number without an x in it, it's always going to be a flat horizontal line. Y equal 2, y equal 4, y equal negative 3. Those all just be flat horizontal lines. Alright, let's talk about domain. Domain is really, algebraically speaking, what numbers can I substitute into that function and get some answer, a legitimate answer. Okay, it doesn't matter what the answer is. When you talk about domain, we're not caring about what the answer is. That we just get an answer. Okay, and when I substituted in x equals 0, I got an answer of 2. When I substitute in x equal 3, I got an answer of 2. X equal 5, I got an answer of 2. X equal negative 4, I got an answer of 2. And I could keep going on forever. I could pick any number I wanted to. I could get an answer. Okay, so that means the domain is every number I can imagine. And there's two ways to write every number I can imagine. I can write it like this with this funny capital R, which means all real numbers. Or I can write it in what's called interval notation and say, well, I can think of any negative numbers as far negative as I can imagine. We call that negative infinity. Or I can think of any positive number. Okay, and we call that positive infinity. Okay, so either way, that means the domain is any number I can think of. Graphically, you can also really tell what the domain is by looking how far left does that arrow go. It goes left forever. The left arrow means this graph will continue to the left forever. And on the right end, that right end arrow is going to the right forever. So you can also see graphically what the domain is. Now, what's the range? The range is the answers you get. Okay, range is the answers you get when you substitute. Okay, sometimes they'll call it output. The domain will be input, numbers you substitute in, range would be answers or outputs that you get. Well, when I substitute in a 3, I get out 2. When I substitute a 5, I got a 2. When I substitute a 0, I got a 2. No matter what I substitute into this function, I got an answer of 2. So the range is just a single number. The range is just a 2 in this case. That's not typical of linear equations. It's only when we have horizontal lines that we get a range of just a single number, but it can happen. Alright, IOI is my abbreviation for interval of increase. Which just means more simply, graphically, is where is the graph going up? Or I think of it as uphill. Now, when I do this, I tell students to imagine that you're going to put a little person as on the left end of this line. Okay. All right. So I'm going to put a little person here on the left end, as far left as I can get. When I do an interval increase and interval of decrease, I'm always making my little person go to the right. Don't ever make him go to the left when we're doing interval of increase or interval of decrease. So as I set my little person to the right, where on that line is he going up? That's increase. He's not ever going up. He's never going uphill at all, ever. So in this case, it does not have an interval of increase. He's never going up. Okay. IOD is interval of decrease. Interval of decrease. Where is he going down on that graph? He's never going down. He's walking on that blue line. He's never going to go down. So in this case, it does not have an interval of decrease. All right. X-intercept or intercepts, okay, means where does the graph touch the x-axis? Well, the x-axis is that black horizontal line, and the graph is the blue there's the x-axis down there. The graph is up here, and it's level. It's never going to touch the x-axis. Never. Not touch the y-axis, but the x-axis I'm talking about right now. The x-axis, the horizontal, it's never going to touch. So it does not have an x-intercept. Okay, in this case, it doesn't have one. All right, now y-intercept is where does the graph touch the y-axis? Okay, the y-axis is going up and down. Well, it touches it right here. And what y value is that? It's a y value of 2. So y-intercept is 2. Okay, not hard. Okay, RE is my shorthand for right end behavior. It's an abbreviation for right end behavior. So what would this graph of this function do as you go way to the right on the x-axis? Like we have a point at 3, we have a point at 5. This is a 6 right there, that's 7, that's 8, that's 9. What would happen when we get to 10 or 11 or 20 or 100 or a million or a billion, or as far to the right, as big as the biggest possible number you can imagine? What is the graph still doing? Well, it's not hard to imagine. It's always going to be just a flat level line forever and ever. So the y value in right end behavior right and left end behavior are really just y values still. The y value would be 2. It's always going to be 2 above the x-axis. So right end behavior is 2. Let me write it differently. Write it like this. As x, I'm going to use an arrow here, that means approaches, because we can never get to infinity. We can never settle on a huge positive number, because we can always think of a larger one, so we say that arrow means approaches. As x approaches positive infinity, meaning the graph goes to the right forever, comma, what's the y value? In this case, the y value will always equal 2. Okay? Alright, LE means left end. Left end behavior. Okay? Alright, now I'm going to change it up a little bit here. I'm going to still put my little man here. But this is the one case I want you to imagine him going left. What would happen to this graph as he goes this way, to left? Well, okay, it's pretty clear to see that it's always going to be 2 again. It's just going to have a height of 2. It's always going to be 2 blocks above the the x-axis. So how do we write that? As x, always start with x, approaches. Now, what would we say when we go left? We're talking about negative a million, negative a billion. We call that negative infinity. Negative infinity. Alright. How high is the graph going to be above the x? It's going to be 2 blocks above the x-axis. So y equals 2. Alright. Let's try another one. Alright. The next graph we're going to do is this one. Very important one. Important linear function. It's going to be y equals x. Now this one does have an x value in it. So first of all, how do we graph it? We're going to pick x values. Okay? So the simplest x value I know to pick is 0. And of course you see 0 here on the x-axis right there in the middle. It's called the origin. So if y equals x and I take that x out and replace it with a 0, y is equal to 0. Okay? So when x equals 0, y equals 0. So my point is going to be right here at the origin. Okay? So I plug in 0, I get a y answer is 0. Alright, let's pick another positive number. That's typically what most people do. They'll pick positive numbers, but don't forget to pick negative numbers. Okay, let's pick right there, that would be x equals 3. That's 3 places to the right of the origin, 3 blocks to the right, 3 lines to the right. Okay, so if we plug in 3, there's nothing to do except say the answer is 3, because there's nothing in front of that x to multiply it by. There's nothing behind that x to add or subtract to it. Okay, so y is 3. So where's y equal 3? Well, start at the middle, go up 1, 2, 3. So where the red 3 and the blue 3 meet, that's where I put a point. Right there. That's when I plug in x, I get 3. And by the way, the notation would be x is 3, y is 3. Okay, that's the coordinates of that point right there. Okay, so let's pick another x value. Let's pick x equal 8. Okay, so way over here is x equal 8. Okay, well again, if x is 8, y is 8. So go up here. Let's see, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 7, 8, 9. Where the blue 8 and the red 8 meet, that's where we put the point. So it'd be right there. Okay? So try not to leave out negative values. Okay, let's say we pick x equal negative 4. So negative 1, negative 2, negative 3, negative 4. So let's pick x at negative 4. Alright, put that in for x. Y is negative 4. So negative 1, negative 2, negative 3, negative 4. Where the blue and red negative 4s meet, there's a line. Alright, so we got 4 points. Really, you don't only need 2 points to draw a line. Just for a tip on graphing, you probably want to keep your line, pick your points. It's going to be uh, quite a bit apart from the others, so it makes your line drawing easier. Alright, so let's draw our line. Okay, and there is the line. The blue line is y equals x. Okay, alright. What's the domain? Again, what can we substitute? Alright, the definition of domain, my definition. What can we substitute? And get an answer. Doesn't matter what the answer is, we're fine if we get some kind of answer. Alright, we substituted 0, we substituted 3, we substituted positive 8, we substituted negative 4. We always got answers. And we'll always get answers. Okay? So just like the first problem, all real numbers. Or we say any number, any negative number we can imagine, that's negative infinity, any positive number. From 0 to a really large negative number, 0 to a large positive number. Alright, range. Okay, range. Now range, okay, let's go back to domain just for a second. Domain are x values. What do I plug in? Alright, range are answers, or y values. What kind of answer do we get when we substitute in our x number? Well, I go over to the y value. So if this dot right here, I got a y value of negative 4. Right here I got a y value of 0. Right here we got a y value of 3. Right here we got a y value of positive 8. So we get negative answers, we get 0, we get positive answers. We'll get every number imaginable. If we just pick x correctly, we'll get any y value we imagine. Okay? So our range is the same as the domain. Even though that capital R really looks the same, it stands for different things. This red capital R means our y values, our range. The blue one meant our x values, our input. Alright, and we can write it just like with interval notation. Alright, interval of increase. Okay. This one might be a little more interesting. Okay, I'll put my little person over here. Always put them on the left end, as far back as you can. Make him always go to the right when you do an interval, and when you interval of increase and interval of decrease. So as he's going to the right, you can see he's going uphill. He's increasing. Okay, so interval of increase means this. For what x values, and I have to emphasize x values because students will think about y values. Okay, for what x values does the graph go up, increase? Okay, so okay, from this dot way down here, this red dot right here, to the right, he's going up. Okay, so the students will say, well, that's at negative 4. Go up here to the x-axis. Okay, at negative 4. At x equals negative 4, he's starting to increase. At x equals 0, he's going up. At x equals 3, he's going up. At x equals 8, okay, he's going up. And you can imagine at x equals 9 is going up. At x equals 10, so on. So it's going up. Now, if this is a problem students will have, you say, well, you put your little man right here at negative 4. I'm going to say from negative 4 to infinity. But that would not be correct, because I can start my little man, I can put a dot here at negative 5 and start my little person back here, and he's going up. I can start my little person at negative 6, at x equals negative 6, and he's going up at negative 7, at negative 8. I got to use your imagination sometime on these problems. I can start as far left as I can imagine, which is negative infinity. So that's where the interval, that's the interval he's increasing. All right. What's the interval of decrease? Where on this, as you go to the right, now don't make him go backwards. Don't make him go left. Where is he going up? And where is he going down for interval of decrease? He's never. This one doesn't have an interval of decrease. And that's typically what you're going to find with linear functions. Either the whole thing's increasing or the whole thing is decreasing. Or if that's not if that's not happening, then it's just going horizontal and not increasing or decreasing anywhere. Alright, so interval of increase is everywhere, interval of decrease is nowhere. X-intercept. Alright, where does this blue line cross the x-axis? Again, x-axis is the black line going left to right, horizontal. Okay, it's crossing right here at the origin. Where is that on the x-axis? That's at x equals 0. Okay, x-intercept is 0. The y-intercept, where does it cross the y-axis? The y-axis is going up and down. No, it's not crossing up here at 4. No, or at down here at -2. No, it's crossing on 0 on the y-axis also. Okay, the right-hand behavior. Okay, what's happening as our little person is going to the right? He's going right. He's way up here. What's our y value? When right here, the y value is 8. If he's right here, the y value would be 9. If I extend that line, go back over here, the y value is 10, and so on. It keeps going up. 8, 9, 10. It's going to eventually get to 100 or 1,000,000. So we're going to write it this way. As we go to the right, so we approach, that's what the arrow means, to the right, positive infinity. Don't put the right infinity there, not negative, positive. Okay? The y value is also approaching infinity. Oh, they're the same exact thing, but those infinities mean two different things. This infinity means we're going right forever. This infinity means we're going up forever. So the infinity sign could mean a couple different things. It could mean we're talking about right or up. Okay? Left hand. Okay. Alright. Coming over here. Take my little man off. Okay. This is the one case I make him go to the left. Okay. So as we go to the left, okay, we're at -4. Let's see, we're here. Our left is at -6. We keep going to the left. We get here. That's -7. Keep going. Way over here. That'd be -9. Okay. We keep getting lower and lower. So how do you write that? As x. I always start with x. This time we're going left. Okay. Okay. This one means we're going left forever. Alright. What's happening with the height of the line? How is it's getting further and further below the x-axis. So, and that negative infinity means down. Alright. Very good. Okay. Y equal x is a parent function. Okay. Everything I'm going to show you from now is really an adjustment. Instead of doing, like you've probably been taught, making an x, y value, okay, that's not terrible to do, but the problem is, you're going to ask you, what do I pick for x? Oh, do you always pick the same thing? No. We have to be more efficient on our graphing. Say, well, when I'm doing this one, which is your problem right now, y equals 3x, how do I change my y equal x? If I learn how to change that, then I don't have to do an input-output table chart. Okay? Alright, so here's here's a definition. The number in front of the x is called your slope. And when you see a number behind the x, that's the y-intercept. That's the y-intercept. Okay? And y equals 3x, you don't see a number behind the 3x. That means the y-intercept is 0. So how do we graph this? Okay? I could say, well, let's pick some x values and plug them in, and that would be pretty easy to do. We can pick x equals 0. Alright? And this time, when I pick x equals 0, it's going to be 3 times 0, okay, which is still 0, okay? So when I pick x equals 0, my y value will still be 0, okay? So I have a point, again, right there at the origin, okay? Now, what would happen when I pick x equal, let's say x equal 2, okay? X equal 2, okay? It's not going to be y equal 2, it's going to be y equals 3 times 2, which is 6, okay? So in this case, when I go over to x equal 2, I get a y value of 6. So my y value go 1, 2, 3, 4, 5, 6. Okay, so my point would be up here. Okay, alright, and you find out I can't really pick too big a numbers. Like if I pick x equal 5, for example, and plug that in, 3 times 5 is 15. I don't have 15 blocks to go on the y-axis, so I have to kind of think about what can I pick for x. I'm going to pick 3. That's really the biggest x value I can pick, and that 3 times that 3 is a 9. So y value is 9, so that will go up here. Okay, and if you pick a negative number, let's say we pick x equal -1. Okay, 3 times a -1 is a -3. So here's -1 on the x-axis. Here's -1, -2, -3. Alright, where they meet, alright, there's a point also. Okay, so we can do all that, but it's a little more time consuming. Let me give you an alternate method of doing this, which I really hope you'll learn to do. Okay? Alright. Since there's no number, let me start over again over here. Okay? Y equals 3x. Alright, again, since there's no number back here behind x, that means the y-intercept is 0. So what I do is I just go on the y-axis and right in the middle put a point. Okay? Alright? Now what I do is I actually now use the slope. Okay? Slope is 3. Okay? I'm going to make it a fraction. Okay? So I'm going to draw a line under it and just put a 1 under it. Okay? Slope is just, I can always just put 3 over 1 just means 3. So I haven't changed, I just changed the way it looks. Okay, and then slope is rise over run. So if I have 3 over 1, that means my rise is 3, my run is 1. So on this first dot, what I just do is I count up 3, so 1, 2, 3, and go to the right. That's what run would be. Run is 1. Okay, so I'll put a dot right here. Okay, and I can continue that from this point. I can do the same thing. Go right, go up 3, 1, 2, 3, and go to the right 1. Okay, here's another dot, and I could do it one more time. It'll fit. If I rise 3 and go to the right 1. Okay, and I can go backwards, because what I can do is say, well, -3 over -1 would be equal to the same thing as +3 over +1, because the -3 divided by -1 is still +3. So that means I would go left, I would go down 3 and left 1. Okay, so I can go down 3, let's say from this dot, and then left 1, put a point. Okay, I can keep going. 1, 2, 3, go left 1. All right, I can do it one more time, put a point there. Okay, draw our line. Okay, that blue line is our graph of y equals 3x. All right, we can go a little quicker. What's the domain? I can plug in really any positive number get an answer, any negative number get an answer. All real numbers. Okay, negative infinity to positive infinity. What kind of answers can we get? I can get any answer I want. I get positive number answers. I got an answer of 6 right there. I got an answer of 9 right there. I got an answer of -6 right there. Okay, I get any answer. If I pick my x strategically or correctly, I can get any answer I want. Interval of increase. Okay, well, this is really like y equals x. So I put my little person way down here. Make him go to the right. He's always going uphill. Okay, at what x value does he start? Again, don't make this mistake. Say, well, it looks like he's starting at -3 on the x-axis. No, got to use your imagination. I can draw this line longer if I had more, my grid was larger. He can start way over here at -4, -5, -6. As far left as you can imagine, you can put your little man on that line. He's going to go up. Okay? What's the interval of decrease? Again, you always go to the right for interval of decrease and interval increase. He's never going to go down. All right, x-intercept. Where is it across the x-axis? Not at 1, not at 2, not at -1, not at -2. Right in the middle. Right there in the origin, x-intercept is 0. What's the y-intercept? Where does it cross the y-axis? Not here at 2, not down here at -3. No, it's right there in the middle. Right there in the middle of the y-axis. Y-intercept 0. All right, what's the right-hand behavior? Okay, again, at the very end, what's going on? As he's going to the right. Okay, all right, at this spot, y value is 6. At this spot, y value is 7. At this spot, y equals 8, 9. It just keeps going up and up. So as our little person goes to the right, approaches, y value is going up. That positive infinity is right. That positive infinity is up. Okay. All right, get your little man turn around for this one spot. Okay. Get him going this way. So he could hit -6. He keep going left, he's going to hit -7. Keeps going left, it's going to hit -9. Keeps going left, it's going to hit -10. So on and so on. So as it goes left forever. Alright, good. Alright, so what I want you to know is how to do, of course, how to do slope and y-intercept, but just think about this when you compare y equals x. That was pretty easy. The slope, it doesn't have a number back here. The y-intercept was 0. The slope actually was 1. Okay, for this one, this we just did, again, the y-intercept was nothing back there, but this time the slope was 3. This is going to be steeper than this one. This is steeper. Steeper. So larger that number in front, called the coefficient, the steeper your function is going to be. Alright, let's try a function that does have a y-intercept besides 0. Okay, again, the number in front of the x, called the coefficient, has a slope. You don't see a number there, that means the slope is 1. And we're going to use 1 over 1 just a minute when we're graphing this. And the number back here is the y-intercept, which is a positive intercept, which is a positive 3. So let's start easy. Instead of doing a table chart, Let's start with the y-intercept of 3. So on the y-axis, there's 1, there's 2, there's 3. Put a point right in the y-axis. Okay, let's use the slope. The slope, the number in front is 1. Okay, so 1. Don't make it 1 over 1. That means rise. That means go up or down is rise, like you get up in the morning, rise. Run means you go forward or backwards, right or left. They're both positive. We're going to rise up 1, we're going to right 1. So from here, we're going to rise up 1 to right there. We're going to run to the right 1. Okay, rise 1, run 1. I can just keep going on and on and on. I can go backwards. Left 1, down 1. Left 1, down 1. Left 1, down 1. They just hit these little diagonals. Okay, so what would our line look like? Okay, so go like that. Okay, so now how is this different? This is where it's really helpful if you know how is that different, or how is that what's the same, what's different about this parent function y equal x. We did y equal x a couple minutes ago, a couple problems ago. Okay, here's y equal x. There's y equal x. See, same thing, except it's got what's called the same slope, right? See, they're parallel. These green dots, if I drew a line through those green points, it'd be parallel to that blue line. The only thing is, it's lower. It's at the y-intercept of 0. Okay, so if we know how to graph y equal x, we can graph all kinds of other functions. All right, what's the domain? Again, for linear functions, it's always going to be, we can plug anything we want in and get an answer, substitute. It's all real numbers. So it gets kind of monotonous with domain, especially because the domain of any linear function is all real numbers. In fact, the only problem you're going to have with domain is these kind of functions. 1 over x, which is a rational function. Okay, that's going to be restricted. Square root of x, that'll be restricted. Natural log of x, that'll be restricted. Okay, pretty much everything else, you have all real numbers for your domain. All right, range. Okay, y values. Okay, y values. Okay, all right, this point went over here to -2. That's an answer. This point went over here to -4. Okay, even though this one is -6, it'll get lower because I can make my grid longer. I can make my grid longer. It'll hit -8, -9. Okay, this point has an answer of 0. Y values are answers. This y answer 1, 2, 3, 4 is positive 5. That y answer is 7, so on. It's all real numbers. Seems very monotonous, but just try to think it out. Okay, so this means, even though these are the same, this means down to up. Down to up. All right, the negative infinity to positive infinity for the domain, that's left to right. Okay, so you know they look the same. They represent something different. All right, interval of increase. You got it figured out. Always go to the right. He's always going up. Okay, where does he start going up? That's what you got to find out first. Right here? No, right here. Up here at -8 on the x-axis? No. As far, it can go to the left as far as you can imagine. All right, how far right does it go? Is it increasing? Oh, it's going forever. All right, interval of decrease. Now he's going up. Okay, we'll change that so it's not always the same thing. Next problem. X-intercept. Okay, where does it cross the x-axis? Okay, x-axis is the horizontal, way back here. At what x is that? That's -1, -2, -3, -3. What's the y-intercept? Well, you can actually go up here to the function and see, oh, there's my y-intercept. You can look at the graph, say, oh, right here, right there, that's positive in the y-axis. Okay? The right-hand behavior. Okay? Alright, as we go to the right, okay, alright, we're getting a 7, we're getting an 8, we're getting a 9, we get a 10, we're getting bigger and bigger positive numbers. As x goes to the right forever, we're getting bigger and bigger positive numbers. Okay? Alright, just imagine your mind. For just this one spot, you go left. Okay? Alright, we got an answer of -3, then we get an answer of -5, then we get an answer of -6. As you keep going left, we get lower and lower. Okay? So, as x approaches -infinity, goes left forever, y also approaches. Okay, very good. Okay, for this problem, let's give you something, some number besides 1 as a slope, and something besides 0 as a y-intercept. Okay? Alright, slope is 2. Y-intercept, that's 1. Okay, I always start with y-intercept. Y-intercept goes on the y-axis. Y-axis, positive 1 right there. Okay, so point right here. Right there. 1 on the y-axis. Alright, the slope is 2. Okay, you're going to find this much easier than putting an x, y, a t-chart, and picking x values. Because the problem with doing that is what x values do you pick? Okay, alright, you don't have to do all that. 2 over 1. Rise is 2, run is 1. Up 2, right 1. Up 2, right 1. Up 2, right 1, up 2, right 1. When you practice, you get so easy. Alright, left 2. Okay, alright. Now, the x-axis counts as, okay, left, sorry, down 2. Down 2, okay. Alright, the x-axis counts as a line too. Sometimes students ask me that, oh, do I jump over that x-axis? No, that's 1, that's 2, and then go left 1. Okay, so yeah, it just counts as thicker to show that it's x-axis. Alright, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Okay. Alright. Here's our line. Ooh, made green this time. Okay. Domain. All real numbers. Interval notation, same thing, -infinity to +infinity. Range, you see it goes, the graph will go down, the green line goes down, down, it's going to the left, but it's also going down. Range is up and down. Range, up and down. Up and down. Down first. How far down is it going? It's going down forever. Okay? Where up's it going? Okay, all real numbers. Interval increase, same as the one we've done. On the whole x-axis, no matter what x values I can pick, as I pick x values that get bigger and bigger, y values, it's going up, the whole thing. Interval of decrease, none. X-intercept, ooh, where's it cross the x-axis? Well, it looks like it crosses right there. Well, we can kind of guess. You see that it goes halfway graphically. Let's not guess. How would you know for sure algebraically what the x-intercept is. It's very easy. To find the x-intercept, you make y equals 0. You make y equals 0. You make y equals 0 to find the x-intercept. Likewise, if you want to find the y-intercept, you make x equals 0. Okay? Alright, so I'm going to do this algebraic up here. I'm going to say 0 equals 2x plus 1. How you solve that equation? Subtract 1 from both sides. We get negative 1 equals 2x. And you divide both sides by 2. You get x equals negative 1/2. Just like we thought. Okay? Just like it looks like. Alright, what's the y-intercept? Again, you can get it from the equation way up there, plus 1. You can get it right there. Okay, y-intercept's 1. What's the right end? It's the same as the last few examples. As x approaches, as you go to the right, the y values get larger and larger. What's the left end? As you go to the left, y gets lower and lower. Okay? Okay, this is, let's do one with a fraction. Okay? Y equals 1/2 x plus 2. So a lot of times students are a little bit nervous when I throw a fraction in there. Well, it's nothing to panic about. The easiest way again, what's the y-intercept? Don't worry about that 1/2 for a second. Positive 2 this time. Okay? So on the y-axis, there's 2. There's positive 1, there's positive 2 on the y-axis. Alright, the slope is 1/2. Alright, it's actually somewhat easier because it's already a fraction. You don't have to make it a fraction. The rise is 1, rise, and the run is 2. Okay? So from the first point we put, we go up only 1 this time. So this is going to be flatter. You can probably know that already. We only go up 1, and we go right 2. So our next dot's there. So up 1 to there, and right 2. Up 1, right 2. Up 1, right 2. We go backwards and go left 2, down 1. Left 2, down 1. Or go down 1 first and left 2. Doesn't matter. Down 1, left 2. Okay? Alright. Here's our line. Alright. That's our graph of y equal 1/2 x plus 2. What's the domain? Okay. It goes left forever, goes right forever, just like any other linear function. Domain is all real numbers. All real numbers, same way. What's the range? Alright, now this one's going up. Hopefully it doesn't cause any problem, but from this dot, let's say, my answer is 0. I got an answer of 0 right there. From this point, I go over here, my answer is negative 1. From this point, negative 2. So you might think, oh my gosh, the lowest it ever gets is negative 2. No. You got to use your imagination. As this line goes left, it goes lower and lower. We can keep going. There's going to be some place over there. You can answer negative 3 or negative 4, so on. Same thing this way. These are our answers. Our y values are answers. That's 4. This answer, at this point, our answer is 5. Our input was, let's see, down here, 1, 2, 3, 4, 5, 6. My input was 6. My output was 5. 6, 5. Plug in 6, I'll get an answer of 5. Okay? If I plug in 8, which is part of my domain, my answer is 6. 6 is part of my range. If I pick strategically, I can get any answer imaginable. Interval of increase. Okay, you wouldn't have to draw your man there. I just like drawing things just for the illustrative. He's always going uphill. The whole line, which goes forever and ever. Done. Okay. X-intercept is right here. The x-axis, where's it at? -1, -2, -3, -4. You could also find that by making y equals 0 in this equation. You subtract 2 from both sides. You get -2 equals 1/2 x. And to get rid of that 1/2 in front of the x, and that's what solving an equation is getting rid of things around the x. You multiply it by the reciprocal, both sides. 2 over 1 is 2. 2 times a -2, that's a -4. Okay, so you can do it algebraically. The y-intercept, alright, here it is right here. Okay, it's 2 placed above the x-axis, so the y-intercept is 2. Of course, again, you can see it from the function equation. The right-hand behavior, okay, it's going up. So far it's the same as x approaches positive infinity. You always start with x. Y approaches positive infinity. That means you're going right. As it goes to the right, the graph is going up. Alright. Left-hand behavior is x is going to the left. So say negative infinity, that means we're going to the left. This time the graph is going down. Okay? Good. Alright, just a couple more examples. Finish this up. All my graphs so far have been going up. Let's pick one that'll go down. So the way I make any kind of graph go down is put a negative in front. So y equal -x. So how does that relate to y equal positive x? Well, y equal positive x went like this. There's a point at the origin, and went up one, right one, went up one, right one. Alright, went left one, down one, left one, down one. Okay? That's what y equal positive x is. What would y equal -x mean? Okay, well, I took the time to plug some numbers in, which you can do. If I plug in 0, what's -0? Well, there's no such thing as a -0, really not a positive 0 either. I still get a 0. So just like y equal positive x, I'm going to have a dot, a point, right here at the origin. Okay? Alright, if we plug in a positive 2, well, that negative in front, change that to a -2. So this time when I plug in positive 2, here's positive 1, here's positive 2 on the x-axis. I have to go find where -2 is on the y-axis, not positive 2, -2. So where the blue positive 2 and the red -2 meet, that's where I'm going to be. Okay, let's pick another one. Okay, 5. Okay, alright, -5. So here's 3, there's 4. So that's where 5 would be on the x-axis. The number you substitute. Where would the answer be? The answer would be -5, which should be on the y-axis. The y-axis is where the answers are at. So where the blue positive 5 and the red -5 meet, that's our point. Okay? Alright, and let's pick one negative number just to be more complete. Let's say we pick -3. Alright, don't let that bother you. It's going to be a negative of a -3. It's like this. Or it could be, written like they put a little negative sign up higher there. The negative of a negative, that keep change business, that negative just means a positive. So our answer when we plug in a -3 is a positive 3. So here is, let's see, -1's right there, -2, -3, okay? Alright, I'm looking for positive 3 in the y-axis. There's 1, there's 2, there's 3. Okay, so the dot will go there. There's my line B. Okay? Just think about the slope and y-intercept for linear functions. Okay? Alright, y equal negative x. Alright, the number back there is our y-intercept. You don't see any number there. Means the y-intercept is 0. Okay. Alright, and that number in front of x, coefficient, that's the slope. Alright, so just like a couple problems, our y-intercept is 0. Put a dot point right here at the origin. That's our y-intercept is 0. Okay, what's our slope? Okay, I can always add a 1 there. Okay, it's understood, so that means a negative 1. Make it a fraction. Just put a positive 1 underneath it. Don't mess around with the signs. Whenever you change a number to a fraction, put a positive 1 in the denominator, not a negative. Just because the top's a negative, don't make it match in the bottom. Always a positive 1. So our rise is negative 1, which means we go down 1. Okay? And our run is a positive 1, which still means we go to the right. Positive run means they go to the right. Negative run goes to the left. Alright, so from our first dot, we're going to go down 1 and then right 1. Going down 1 there, right 1 there. Okay? Again, just follow, keep going. Down 1, right 1. Down 1, right 1. Down 1, right 1. This is always going to be in these diagonals. I'll go up 1, left 1, up 1, left 1. It's not hard. Okay, draw your line. Again, you don't need all those dots to draw a line. Just makes it a little more accurate if you're drawing on, a sheet of paper instead of on, electronic like this. Okay, domain. All right, I substitute any number I wanted to. Right here, we substitute 0 in. All right, we got, see, these are what the x-axis. This is what our domain is. We used 3. We used 5. We got an answer. All right, we used 7. Okay. Okay. We used when we plugged in -2, we got an answer of +2. When we substituted -5 for, okay, we got an answer of +5. So we substitute any number you can imagine. Again, linear functions. Domain is always, 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 always all real numbers. Any number you can imagine. Range, okay, this goes a little backwards from our previous examples, but do we get a bunch of negative numbers? Sure we do. Over here, go to the y-axis. Go to the y-axis for your range. That answer is a -8. This point right here means our answer is a -8. This one's a -9. Okay. All right. This answer was a +3. Doesn't matter which direction we go. We just get answers. Doesn't matter if you plug in positive numbers first and get positive answers, or if you plug in positive numbers and get negative answers. Doesn't matter. We're just getting negative answers. Any negative answer we can imagine. Okay. Any positive answer. So, and typically this is what linear functions look like. Alright, interval of increase. Okay, this will be different, as you can imagine already. Start your little man as far left as you can imagine. Even just visually, you don't have to actually draw him. Make him go to the right, always. Alright, so this time what's happening? As he's going, where's he going up? He's never going up. So if you have a negative coefficient on a linear function, it doesn't have an interval of increase. It has an interval of decrease. So it doesn't have an interval increase. I know we've been putting there all numbers every single problem, but you got in the habit. But no, not always going to be that way. So this, when it has a negative slope, like this one does, it's not going to have an interval increase. It's going to have an interval decrease. All right, what's the interval of decrease? All right, well, let's see. At x equals 8, the green line is going down. At negative 8, x equals negative 8, the green line is going down. At x equals negative 6, the green line is going down. At x equals negative 3, the green line is going down. All right, again, don't make that mistake and say, well, starting at negative 8 on the x-axis, try to write negative infinity. At negative 8 on the x-axis, he's starting to go down. No, at negative 9, he's starting. When he goes right, he's going down. At negative 10, as far back as you can remember. So I was, it really is negative infinity, not negative 8. So negative infinity to positive infinity, he's decreasing. Or you can say the whole x-axis. X-intercept, we're in the x-axis. Right here at x equals 0. The y-intercept on the y-axis, also y equals 0. Alright, now the right end is going to be a little different. So imagine your little guy is over here. He's going to the right. Just like for intervals increase or decrease. Alright, this time, as he keeps going right, the numbers get lower and lower. Negative 7. Negative 8. He goes a little further right. It gets a little bit lower. He goes a little farther right. The answer gets a little bit lower, negative 9. So this time, as he's going to the right, approaches positive infinity, this time he's going down forever, negative infinity. This is right, this is down. Alright, turn your little guy around for this one spot. Left end behavior. Okay, this time as he's going left, alright, that's a 7. He gets a little farther left. That's an 8. He goes a little farther left. That's a 9. So as he keeps going left, the numbers get bigger. So as x approaches negative infinity, goes left, the y values get larger, positive infinity. I know the right hand, left hand throw a lot of people. Alright, we're coming to the end. Okay? Now, my functions so far have been written in what's called slope-intercept form. Okay? I'm going to write one that's not in slope-intercept form. Alright, this form is called point slope form. Which when you get to calculus, it's going to be a lot more like that than slope-intercept form. Okay, and it's not hard. Okay, what you do is we got a point and we got a slope. Let's start with the slope. We graphed our point first. Okay, this number back here is still the slope. Okay, it's in front of x, even though we have a parenthesis here. Okay, all right, these two numbers right here. These other two numbers, they're going to make our point. Okay, this negative 1 is right behind the x. So I'm going to say, and all I'm going to say is the x coordinate of this point. Now this is not an interval, it's a coordinate. So parentheses can sometimes stand for coordinates. They can sometimes stand for points. So I'm going to change that sign from negative 1 to positive 1. Okay? And here's my y value, that plus 2 behind the y, that goes to the y. Change that sign to negative 2. So what happens is I know this line is going to go through the point 1, negative 2, and it's going to have a slope of positive 2. So this is how I graph it. Okay? I don't go ahead and do an XY chart. Oops. Okay? Because again, the hard part is what on earth do you pick for X? Okay, you're just picking blindly. We can be more strategic. We can go quicker. Okay? Alright, so 1, -2 means, let's see, go to the right one on the positive x-axis, which is right there, and -2 on the y-axis. Where they meet, that's where that point is. Okay? So, there's 1 point in my line. Okay? And I really only need two points to draw a line. Okay? I'm going to use my slope. The slope is a 2. I can always change a slope, a number that's not a fraction to a fraction. Just put a +1 under it. Don't just put anything under it. Put a +1. Don't put a -1. Always a +1. Okay? Alright, so that means go to the right one. From any dot that's on that line. We already have a dot, go up 2 and right one. Okay? So here we go, up 2, that's 1, that's 2, it's going to be on the x-axis, go right 1. Okay? Up 2, right 1. From there, up 2 and right 1. Up 2, right 1. Okay, very easy on the Promethean board. Okay, down 2, left 1. Down 2, left 1. Or left 1, down 2. Doesn't matter what order you do them. Alright, so here's our line. Okay, what's the domain? Again, just like any other linear function, all real numbers. What's the range? Well, if I pick carefully, I could get any number I wanted. If I wanted to get a value, a y value, let's say this one right here. That y value is -1, -2, -3, -4, -5. That y value, that answer is -6. What x value do I have to pick to get that y value, -1, -6? Well, I had to go up here to -1. If I would have put -1 in this function, okay, I would have had y plus 2 equals 2 times -1 minus 1. Y plus 2 equals 2 times -1 minus 1 is a -2. Y plus 2 equals 2 times -2 is -4. Subtract 2 from both sides, -6. Okay, so to get a value of -6, I could have picked -1. But the thing is, for range, okay, I can get any answer I want if I just pick the right x. And you don't have to pick the right x, you just got to know that you can get any y value you want. So again, range, which is pretty typical. I mean, unless it's a horizontal line, that's what always your domain and range is going to be. Go back to the first example. Interval of increase, again, we're going back to this. This one is increasing from left to right. So it's on the whole x value range. I mean, on any x value you think of, it's increasing. Okay, interval will decrease. No, it's never going to go down. You always got to go to the right. Always to the right. Always. Always go right. X-intercept. Okay, here it is. On the x-axis, 2. Y-intercept. Well, it's hard to see up here in the equation because it's in point-slope form. If it's in slope-intercept form, it'd be easy, but it's not. So, graphically, what is it? Y equal -4. Okay. Again, find the y-intercept, you can make x 0. Okay. So, I won't go through all that. It's a lot of stuff to do, so I won't go through algebraic, but it can be done like that easy. The right end, okay, as your little guy goes to the right, this y value was 1, 2, 3, 4. As he goes a little further right, that y value is 6. As he gets a little farther to the right, this y value is 8. So as your x values increase, the y values also increase. Okay, left-hand behavior. Alright, make him go the other way in this one time, this one place. Make him go the other way, make him go left. So this time you get a -6, and this time you get a -8, and you'll get a -7. So, you know, don't think you're skipping just because I'm skipping numbers there. I'm just going finding the points that are graphed. Get a -6, then a -7, then a -8, -9, so on. So as x approaches negative infinity and goes left, y approaches negative infinity. Okay, one more. Alright, this last equation I'm going to use is not really a function. Okay? Alright, it comes up every now and then. Okay? This I'm going to write like this. I'm going to say x equals 3. Okay? Doesn't say y equals 3, it says x equals 3. If it was y equals 3, it'd be this horizontal line right here. You know, 3, 3. No matter where I go on the x-axis, 3, 3, 3, 3. Okay? Alright. Alright, this is not what I want you to graph. So hold on. This is y equals 3. Okay? This says x equals 3. So the way we do this line, okay, we put wherever we go on the up and down and say, well, here x equals 3, and here x is equal to 3, and here up here is x equals 3, and here's x equals 3, and here's x equals 3. So this one is a vertical line, and it's not a function. That's why I'm not calling this. This is definitely a function, even though it says function right here. Okay, this is not a function because literally a function is a vertical line test. If I draw a vertical line through, a function like that, any vertical line will touch that graph only at one spot. Well, this one is not a function because if I draw a vertical line right through here, oh, it hits that line in all kinds of spots. In fact, an infinite amount of spots. So it's not really a function. It's a function. When we talk about functions, really, almost all the time, function of y in terms of x. That's what we do almost all the time. This one really, if you want to call it a function, is x in terms of y. Okay? So x in terms of y. Even though I don't have a y in there, no matter what I pick for y, y is 0, I get x equals 3. Y is 3, I get x equals 3. Y is 7, x equals 3. Y is -3, x equals 3. No matter what I pick for y this time, I get x equals 3. Alright, so just to go over this because sometimes you'll catch on this. What's the domain? Okay, what's the only, what does it have for a domain? Well, typically we don't say it has a domain and range because it's not a function of it's not a function of y in terms of x. So I don't even describe a domain and range for this one, okay, because it's not really a typical function like we think of. Interval of increase, interval of decrease, okay, not really. It's a vertical line. It's a vertical wall, okay. We don't say it has an interval of increase when it's straight up and down, okay, or decrease. X-intercept, we can say it has an x-intercept of 3 because it does cross right here at 3. Okay. Doesn't have a y-intercept? No. None. We don't need to talk about right end and left end behavior because the graph doesn't go right, doesn't go left. So really the point of showing you this is just to show you how would you graph something like this. And just remember, it says x equal number, vertical line. If it said y equal number, that's a horizontal line. Okay, so when we have a vertical line, none of these characteristics really, not too many of them we can really address very well. So just want you, if it just starts x equal, always remember it's a vertical line, how to graph it. And that's it. Very, very good.